Okay, so we're looking at this example here where we want to take the number 2.718281828, repeating, and we want to write that as a fraction. Now I chose this example because if you look at the natural exponential base raised to the first power, uh, it actually starts out with this repeating pattern for the first two times, and then it switches, of course, to something else because it doesn't repeat. It's not a repeating pattern. But we had 2.718281828. So my thought here was, well, what if it had been a repeating decimal, which the natural exponential isn't? What would that look at? What would that fraction look like that would give you that decimal? So that's what kind of why we're looking at this example. Thought it was a good example, and it also shows us one with a bigger repeating pattern. So the first thing we would do here is strip off the 2.7, and we would just focus on the repeating part, 1828, repeating, right? And that's the piece that we're going to set up and do our geometric series for. So first term there, focusing on that, would just be 0, 1828, and then plus, and then you'd have 5 zeros, and then 1828 again, and so on and so on. I'm not going to write any more of those down. So that means my A term is just that 0.01828. And then what's happening is when you get to the next one, it's 4 places over. Moving it back 4 places to make it smaller would be the same as dividing by 10,000 or multiplying by 1/10,000th. So that's what's happening. Every time it's going to move back 4 places. So we multiply by 0.0001 to the k. And this would be the sum as k goes from 0 onward to infinity. So now that we've expressed it as a geometric series, we can, of course, compute it and see what it converges to. That would be my numerator, 0.01828, divided by 1 minus 0.0001. So this works out to be 0.01828 on the top over 0.9999. Okay. So to simplify this, we would move the decimal place over 1828. So we'd move it 5 places on the top. So we would also move it 5 places on the bottom. That would make that 99990. And then I'd want to reduce that as much as I can. So I'm just going to jump onto a calculator here and do that. 1828 divided by 99990. There's my decimal. You can see it's 1828, 1828, 18, and then it's rounding off. So in the display. What's that as a fraction? Fraction is actually 114 over 6249. 114 over 6249. So it actually does reduce there to 114 over 6249. Okay, and then to finish the problem off, we wanted to write the 2.7. So I take that and add on to it 2.7. Well, what's 2.7? 2.7 is 27 tenths. Right, that's 2.7 plus that number, 114 over 6249. Right, and then we simplify. And again, I'm just going to use my calculator to do it here. 27 tenths plus 114 over, was that 6249? 6249. So now, you just want to check and make sure that's right. Hold on. I'm sorry. That is not correct. Because my calculator is actually rounding that off. So that is wrong. I'm sorry. That is not 114 over 6243. In fact, if I check on my other calculator, 114 divided by that result, 6249, is 1824. Yuck, calculator. Why would you lie to me like that? Why would you lie to me like that? 114 over 6249. That is not what it is. So I'm sorry. I was relying on this calculator, and I'm sorry, it's not working. That is incorrect. I was actually relying on my calculator there, and it's lying to me. It's simplifying stuff and giving me something that's just not true. So 1828 over 99990 does actually simplify. We can take a 2 out of it that I do know of. That would take me down to 914 over 49995. And I don't know if that reduces anymore or not. But I'm going to add that to 27 tenths. 914 over 49995. Okay. So what I do know is this much. To get from 10 to that, the thing we're going to need to have is a 99990 common denominator so that the 10 will build with that. So I'm going to have to multiply that denominator by 2, and I'm going to have to multiply that denominator by 99990. Okay, so if I work this out, the 10 will have to get multiplied by 9999, right, to get the 9990. And then the 49995 will have to get multiplied by 2. So I actually shouldn't have simplified it. I should have just left it. But that's all right. We live and learn. So working that out, the numerator would be 27 times 9999 plus the other numerator, 914 times 2. And that gives me 271,801. 271,801. Over 99999. There we are. 0. Okay, so there's everything written as an improper fraction. Okay. Does that simplify? I don't know. I'm not trusting my calculator that's built in here because I know it rounds stuff off, and it just lied to me a moment ago. So I'm going to go over to Wolfram Alpha, where I can actually plug that in. And I know Wolfram Alpha is not going to let me down. So there it is, my input 271,801 over 99990. And it tells me I can't reduce that. And it demonstrates to me again that that we have the pattern there, 2.71821828 forever. And it even mentions that we could write that as a mixed fraction 2 and 71821 over 999990. Okay, so there it is, my number, and it again is exact. So being careful again with technology, which doesn't always agree, especially when I'm using my little calculator. Really didn't think it was going to be that crazy, but yes, it is. So there it is, written as a fraction, not the nicest fraction in the world, but it is the fraction that does what we want it to do. in this example. So